Hello, I J. Vijay Chandra welcomes you to Wits Connect. Today, as part of computer architecture and organization, today's topic is address instructions. Address instructions. Address instructions. As part of address instructions, there are 0 address instruction, 1 address instruction, 2 address instruction, and 3 address instruction. So, the address instructions are of mainly 4. One is 0 address instruction, 1 address instruction, 2 address instruction, and 3 address instruction. First, we are going to discuss regarding the 0 address instruction. So, the computer is meant for to do tasks. To do a particular task, we need some instructions. The instructions should be done by the computer. Based on our instruction, it will perform the task. So, what computer will do? A computer performs a task on the basis of the instruction provided or given by us. Based on the instruction provided, a computer will perform the task. An instruction is a command that is provided to the computer to perform a particular task which is given or which is asked. So the instruction in a computer comprises with the group of fields. So the instruction is a group of fields. An instruction is a group of fields. As a computer will understand only 0 and 1, this group of fields contains only binary numbers. This group of fields contains only binary numbers, that is 0 and 1. So, among the address instructions, the first one is the 0 address instruction, 1 address instruction, 2 address instruction, 3 address instructions. Then, the 0 address instruction, before going to the 0 address instruction, the address instructions are operated by, first one is single accumulator organization. Single accumulator organization. Next one is general register organization. The third one is stack organization. In 0 address instruction, we are going to see using a stack address or stack organization, whereas we will use accumulators and registers, and the method we are going to follow is the stack organization. Let's take an example. A plus B, C plus D. Here, first one is the operation field. The fields used here are, first one is the operation field, that is plus asterisk. These all comes under the example plus. This is the operation field. Then comes to the address field. Address field. This address field is for the register and memories. This address field is for the register and memories. Next comes to the mode field. Next comes to the mode field. It is how the operand is found. That means where we are going to get the operand. How we find operand. Okay, how to get the operand. That means how to get the value. So once again I am going to discuss regarding the instructions. Address instructions. What we are discussing is the address instructions. Among them there are four. One is 0 address instruction, 1 address instruction, 2 address instruction and 3 address instruction. A computer is, as part of computer architecture and organization, computer is a machine which will perform tasks based on the instruction given by us. So it will use the memory to perform the instructions. So there are, from the memory there are registers as well as memories. And the mode of the field is the performance where it is found. And the operation field is addition, subtraction, multiplication, division, whatever the operation we are going to do. So the address instructions are mainly of three. One is single accumulator organization, general register organization, stack organization. So in stack organization we are going, the 0 address instruction is mainly based on the stack organization. We are taking an example, A plus B into C plus D. We are using this for postfix. Postfix declaration. Okay, so we are going to use postfix. What is postfix? There are three types of. One is prefix, that means A plus B in prefix will be denoted as plus AB. Next is infix, that is A plus B. It is A plus B in between only. Then it is postfix. A plus B will be denoted as AB plus. Pre means first the operand will come, then the things. Here it is prefix. So what we have to do? We have to do the calculation for A plus B into C plus D in the postfix. Okay, first I will do a general method where you can understand easily, then using the stack. Okay. In general method, A plus B asterisk C plus D. This is T1, this is T2, then star. T1 equal to plus AB, T2 equal to plus CD, then T1 star T2, T3 equal to asterisk T1 T2. Now we will calculate this. Star T1 value plus AB, then T2 value plus CD. So this is the output for the prefix. This is the output for the prefix. What we need is the postfix. For postfix, the same thing, A plus B asterisk C plus D. This is T1, this is T2. T1 equal to AB plus T2 equal to CD plus then T1 asterisk T2 T3 equal to T1, T2 star, then T1 value AB plus CD plus asterisk. This is the output. So this is the postfix. This is prefix. Now using the stack operation. Using the stack operation, how we are going to do? So this we have to do postfix. So push A is the first step. We are pushing the A value into the stack. If this is the stack, we are pushing A value into the stack. Then push B. So we are pushing A, then we are pushing B. Then add ADD. Add, that is at the top you are going to get plus. Okay. Then comes to next step, push C. Then the next step is push C. Then here A, B plus then C. Then push D. Then D. Then add plus symbol. After this, we are going to use this operand. Okay. So then mul. So the output will be like this: A, B plus C. So the output will be A, B plus C, D plus asterisk. That is of mul. So output is A, B plus C, D plus asterisk, as same as previously did. So this is about the using of stacks to complete this equation, that is notation is A plus B in braces into C plus D in braces, that is of postfix. So this we are going to generate by stack operation, that is zero address instruction. This is about the zero address instruction. Next it is one address instruction. Then we will go for the two address and three address. After the zero address instruction, the next instruction is the one address instruction. The one address instruction is used in memory address instructions, where it is implied by the accumulator. The accumulator register for the data multiplication. One operator is for accumulator and other is for the register. So, and this register or the memory address location will be implied. So, one address register, it is opcode. One address register, it is opcode, and operand or address of operand or address of operand. So the second is operand or address of operand, and next is the mode, MODE, mode. So first one is the opcode, next is the operand or address of operand, next one is the mode. So this is about the one address instruction. In one address instruction, the first one is opcode, next is operand or address of operand, and next one is the mode. So this is about the one address instruction. The same expression we will take, that is a plus b asterisk a plus c plus d. The same instruction we will take, but here we will use AC, which is accumulator. We use AC, which is accumulator, and we will use M, which is a memory location. That means we will use a AC, that is accumulator, and we will use M, that is memory location. Next we will use M of T is a temporary memory location. So in one address instruction, opcode will be there, operand, that is address of the operand, will be given, and mode will be given. And here a plus b into c plus d, this is the equation previously which we seen. AC is an accumulator, M is a memory location, M of t is a temporary location. Then to do the calculation of this particular problem, that is a plus b into c plus d. So for it, first we are going to load load then AC accumulator, where you are going to load equal to M of A. First is we are loading AC equal to M of A. Memory location is given, and that is A we stored in the particular register or memory allocation. Then after load A, the next is add B. Add B. Add B means we are going to add here that AC equal to AC plus M of B. AC plus M of B. So load A, we are loading AC, that is M of A. Then add B, AC equal to AC plus M of B. So here the problem A, brackets of A plus B, okay. Then asterisk C plus D. This is one set, A plus B. So store T, temporary location. What is T? T is the temporary location. That is M of T equal to AC. That means whatever stored here, AC plus B, first AC value is A and next AC value is M of A plus B, that will be stored in the temporary location M of T. So the same equation we are using memory location and accumulator, and we are doing the problem. Is it clear? In the zero address instruction, we use the stack, we use the push option as per the stack instructions. Now opcode will be there, operand will be there, mode will be there. Then A plus B into C plus D, AC is the accumulator, M is the memory location, M of T is the temporary location. So first we loaded A, AC equal to M of A, add B, we added M of B to AC, that will be again stored in AC. So now the AC value is M of A plus M of B, and again that we stored in the temporary memory location M of T. Then again load C. Now AC value will become M of C. Next add B. So the AC value will become AC equal to AC plus m of d. Next, store t. Again one temporary location we taken. So a plus b. This particular set comes under a plus b. Now c plus d. This particular set comes under c plus d. And instead of storing, now we are going to multiply this value is t now. Now this total value is t, and this value we already did. Up to here this value is did. So what I am going to do is mul multiply t, that is AC multiply t AC. Yes, this AC value, that is which is equal to AC plus m of d. Okay, this value I am going to multiply with AC. Then store the store equation x, the output m of x equal to AC. So by this equation we solve this particular problem. Once again I am going to revise. See here, a plus b. For a load A, that is AC equal to m of A, add B, then we are going to add AC equal to AC plus m of B. So this will be added here. Then store T, m of T equal to AC, load C, AC equal to m of C, add B, AC equal to AC plus m of D. Then mul T, AC equal to AC plus m of D. Then store x, m of x equal to AC. So by this we completed the equation which is of one address instruction. This is of one address instruction.